Right, Noora. So, talking about this question, the final question is to determine the empirical formula. So far, whenever we are asked to find the empirical formula on a question, we will be normally given the percentage of the elements present, right? The percentage composition of the element present. So, what do we do? Or at least the mass, like 5 grams, 6 grams, 7 gram, at least the mass present. So, we can easily divide it by molar mass of that particular element and we will have the answers available. We further divide all those three answers by the smallest answer available here in this step, right? And then we will get whole number. Until we are getting whole number, we will have to do that. And you know what to do when we don't get whole numbers, right? But here, this time it's different. It's an equation or a reaction that is given. Furthermore, we have no data about the mass composition or the percentage composition of carbon, hydrogen, and oxygen in that compound. Then we have to think of a way to find either the mass or straight away the amount. Right. We had Cx, that is an unknown value, X, Y, or Z, let's say, reacting with excess oxygen. That's very important. Excess oxygen. You know why it's very important. And that gives us carbon dioxide and water. Right. So the mass of carbon dioxide is given to be 8.802 gram. Mass of water molecule is given to be 3.604 gram, right? Now tell me, out of 44 gram per mole, because 44 gram per mole is the molar mass of carbon dioxide, how do we find that?
You do 12 over 44 times 8.80.
Yes, the reason is out of 44 gram of carbon dioxide, 12 gram is made up of carbon, right? In that case, how much will be the mass of carbon on 8.802 gram carbon dioxide? It's a calculator paper, so you get the mass of carbon. And how much will that be?
2.4.
2.4 gram. You know, we went one more step ahead and then we also found the amount. But let's say you are finding only the mass first, that's still fine. Because we know to find the empirical formula, we need the mass composition or the molar mass percentage composition. So we have 2.4 gram of carbon. We are going to use the same idea to find the mass of hydrogen. And we can use the water molecule for that, right? Out of 18 grams per mole of water molecule, 2 gram will be made up of hydrogen. Then this time we have 3.604 gram. What will be the mass of water molecule?
Um, 0.4.
Yes, 0.4 gram. Now, the hydrocarbon, not just the hydrocarbon, it also consists oxygen. The mass of hydrocarbon or the organic compound, that's the better way to say. Since it contains oxygen, we cannot call it hydrocarbon. The mass is given to be 4.406 gram, right? Already a 2.8 is made up of carbon and hydrogen. So what will be the mass of oxygen?
12 times 2.4 plus 3.60.
Oh
No,
yeah,
plus
but then to do that, we have not found the amount yet. We only have the masses. So 2.8 gram is the mass of carbon and hydrogen. Total mass is 4.406. So only the mass of oxygen will be
um
subtract 2.8 from 4.406. That gives you the oxygen's mass.
okay.
That is 1.6 gram. Am I right?
Yeah.
Okay, then we finally have found the mass. If, as I said to you, if we have the mass composition, we can find the empirical formula. What are the steps? Divide the mass by the molar mass. So
Yeah.
2.4, 0.4, 1.6 by 16 by 1 by 12. It says 0.2, it says 0.4, this is 0.1. Dividing everything by the smallest possible answer, which is 0.1, we get 2 here, 4 here, 1 here. Hence the empirical formula is
H4.
C2H4O. Okay.
Okay.